Hey everyone, let's jump right in. Welcome to this explainer on Markup. I'm speaking directly to you, developer to developer, about a tool that's absolutely going to change how you handle web output in your native applications.
Look, we've all been there, right? Let's just take a second to empathize with the absolute nightmare of hunting down a missing closing div tag at 2 a.m. or dealing with the inevitable memory leaks and honestly, just the sheer ugliness of string concatenating HTML inside C, C++, or Delphi. It's tedious, it's incredibly error-prone, and it really feels like a massive step backward when you're just trying to write clean, modern software.
So, here is our game plan for today. We're going to talk about ditching HTML for good, moving to a one syntax, one rule paradigm. And then we'll get into the weeds with seamless DLL API integration, building custom tags, writing custom functions, and finally, why this is the ultimate productivity boost.
All right, part 1, ditching HTML for good and solving that native WebView headache.
Let's be real, standard HTML is just way too verbose. It's totally error-prone when you're trying to author it at scale inside a native codebase. That's exactly where Markup comes in. It actually compiles down to clean, semantic HTML, but it hands you the power of variables, conditionals, and reusable components right out of the box. And it's Turing-complete by design. You're not just writing dumb tags anymore. You are writing dynamic, programmable documents.
Moving on to part 2. One syntax, one rule. This is a total paradigm shift in how we author content.
The core philosophy here is all about killing ambiguous parsing contexts completely. Just look at the difference. On one side, you have standard HTML with those clunky, repetitive opening and closing tags. But with Markup, you get this incredibly elegant syntax based on a really simple brace, tag, and content pattern. There are no weird mode switches, no special cases you have to memorize. Literally every single construct follows this exact same pattern.
And this brilliant simplicity scales effortlessly to nested elements too. Because we use quoted strings, the parser knows exactly what content it needs to preserve. Everything outside of those quotes, it's just white space. It's literally just formatting that the lexer throws away. So you have absolutely zero white space ambiguity. It is just so much cleaner.
Okay, section 3, seamless DLL API integration. Let's step into the engine room for all you C and Delphi developers. So, if you're building in Delphi or C++, you probably want to know how this actually wires up under the hood, right? The flat C-style DLL API has a lifecycle that is beautifully efficient. First, you just call markup create to fire up the engine. Next, you run markup parse to compile your document into an abstract syntax tree, an AST, and you only have to do that once. After that, you can call markup render as many times as you want, just feeding it different JSON data payloads each time. When you're totally done, markup destroy cleans the whole thing up. Parsing might be heavy, but rendering from that AST, it's lightning fast.
Now let's talk about memory, because nobody wants a memory leak. The API uses this strict, but honestly dead simple, string contract for UTF-8, P, and CHAR boundaries. The golden rule is, you create it, you destroy it. If the DLL hands you a heap allocated string back, you've got to free it using markup free. But if you pass a string into the DLL, it's strictly read-only. The engine just copies what it needs, and you keep ownership of your string. The one exception you got to remember is markup version. That returns a static buffer, so definitely don't try to free that.
All right, let's look at part 4, building custom tags and supercharging this engine.
Extensibility is where this goes from a neat tool to a production-ready powerhouse. You can register custom tags right through the API. You just call markup register tag with your engine handle, the tag name you want to intercept, your callback handler, and a user data pointer. When you do that, your custom tags actually take absolute priority over the built-in markup processing. You are literally extending the language itself to fit whatever your specific app needs.
Once you're inside that tag handler callback, you get access to a render context. It's super safe. You can inspect attributes using markup to CTX Assure, or check if one even exists with markup to CTX has Attr. When you want to output something, you use markup to CTX emit to write raw text directly into the output stream. But here's a massive tip. You absolutely have to call markup to CTX emit children if you want the tag's inner content to actually render. If you forget that step, those child elements are just gone. Discard it. It gives you total granular control over the whole rendering pipeline.
Moving to part 5, writing custom functions for that Turing-complete power.
So it's not just about tags. You can actually register custom functions that you can call directly from Markup's expression interpolations or even use them as pipe filters. When your function handler fires, you read the incoming arguments by their zero-based index using these specific typed accessor functions. Whether you need a UTF-8 string, a 64-bit integer, a float, or just a Boolean, you pull the exact data type right out of the engine.
And once your custom native logic wraps up, you've got to pass a value back, right? You do this by returning a result pointer, using one of the constructors like markup result string or markup result integer. Here is the really cool part. The second you return that result, the markup engine steps in and takes full ownership of the memory. You build the result, hand it off, and the engine takes care of all the lifecycle cleanup for you. It is zero stress.
Finally, Section 6, the ultimate productivity boost and why this actually matters for your native code. Let's pull back for a second and look at the big picture. Why is this architecture such a massive productivity multiplier for native software engineers? Well, you're getting a Turing-complete engine with literally zero complex third-party dependencies. It's just a single DLL or a single header C loader. You get fully thread-safe engine instances with no shared mutable state. Plus, it has first-class JSON data binding right out of the box, and you get pure memory safety thanks to built-in limits on things like iterations, recursion, and output sauce.
The whole philosophy behind this language can really be summed up in one powerful mantra: write documents, not HTML. It completely strips away that tedious, bloated syntax, which means you get to focus 100% on the logic, the structure, and the data binding inside your native apps.
So are you ready to drop markup into your next native project? I really challenge you to integrate this single header loader today. Honestly, you might just never concatenate an HTML string by hand ever again. Think about it. How much time are you wasting right now just fighting with string formatting and tracking down memory leaks? What kinds of incredibly fast native applications could you be building if the friction of the web view was just completely eliminated? Thanks for hanging out with me for this explainer. Now get out there, drop markup into your code base, and see the difference for yourself.